Okay, linear quadratic systems. Alright, so we want to make sure both equations are first in the form of y equals. Alright, so we get them both to y equals. The next step is always going to be to set them equal to each other. Substitution here does work, but I'd prefer to use the setting them equal. Okay, and then we're going to get everything to one side so we can solve. So let's jump right in to this first problem. Set them equal. So 5x minus 20 equals x squared minus 5x plus 1. And again, the reason we can set them equal is because if they both equal y, then they must equal each other. That's the transitive property that you learned in geometry. So we're going to move things over. I'm going to subtract 5x over. Looks like I have the room, so I'll write it begrudgingly. I don't normally do this. Plus 20 plus 20. So we get 0 equals x squared minus 10x plus 21. Now the resulting quadratic that we have typically is solvable with factoring of some sort. This is going to be trinomial factoring. We can use add multiply. So I can have an AM. What adds to 10 that multiplies to 21? Well, there's very few numbers that multiply to 21, and I'm guessing 1 and 21 is not going to make the 10, so probably going to be 3 and 7. So 0 equals, that's supposed to be an equals. I don't know how that just happened. Darn stylus. So 2 sets of parentheses for trinomial factoring. X and x is always going to come first, because conveniently that multiplies to make x squared. We said 3 and 7 are the numbers. We just have to figure out the signs. We'll have to multiply to be a positive 21, so they're both positive or both negative, and since it has to make a negative 10, they both must be negative. Now, the trick is now to set each part equal to 0. This is a step that just about everybody wants to skip and just do in their head, because it's so much easier just to say, hey, switch the signs, which is not what you really want to do when we get to the harder problems. So remember that you are setting it equal to 0, and technically you are adding 3 over and you're adding 7 over, and that is why the signs got switched. Okay? So we get x equals 3 and 7, and everybody wants to stop here, including half my students, it seemed, on the last test that I gave this year. So if you do, you get a 2 out of 4, which isn't a very good grade. For those of you that aren't great at math, that's a 50. So you want to keep going and get the y's. So we need to plug back in. And again, just like in the previous video, let's not choose crazy. Let's choose the easier formula, okay? So when I plug in x, I don't really want to plug it in and square it, multiply it by 5, subtract it, and add 1. I just want to do the easier version. So I'm going to plug it in there. Don't choose crazy, okay? At least not in my math class. Crazy all on your own. Anyways, y equals 5 times 3 minus 20. So that is 15 minus 20, going to give us negative 5. And you can do all that in your head, and that is fine. The next one is y equals, come on, 5 times 7 minus 20. So y equals 35 minus 20, which is 15. And a lot of people want to stop there. And hey, you know, if you stop there, at least you get a 3 out of 4. That's a passing grade. But unfortunately, you're still not done. You need to list your answers as coordinates. Okay, so we need to write 3, negative 5, and 7, 15. So here we have it. This is our 3, the x value that gave us the y value of negative 5, so hence the 3, negative 5. And the x value of 7 gave us a y value of 15, so 7, 15. Those are the answers, and we're in good shape now. All right, example 2. Want to get it set equal to y equal with both of them. So first one is, thank goodness, we just need to add over the 10x. So we're going to get y equals negative 1 plus 10x. Or you could write it as y equals 10x minus 1. You need to understand that you can have both of those. Either one is fine. Typically we see it as like the mx plus b form, so we would normally see the x first. So I'm going to go with this one. But it doesn't matter if you did that one. It really isn't going to make a difference whatsoever. So we're going to set them equal, because if they both equal y, then they must be equal to each other. So I have a 10x minus 1 is equivalent to y, and I have a lovely 3x squared plus 21x minus the big old 5er. So we need to start moving everything to one side. I'm going to subtract 10x and add 1. So you can do this in your head, so can I. So when I subtract 10x from 21x, I get 11x, positive 11x. When I add 1 to negative 5, I get negative 4. And look at that, this problem doesn't work out to be so nice. And this is the question I was referring to up above when I said you really want to set it equal to 0. But anyways, this is going to be your tricky try. So we're looking at it. What are the numbers that are going to multiply to 3x squared? Well, that's pretty easy. You got to have a 3x and an x. And then you ask yourself, what multiplies to 4? And hopefully that isn't too hard. I don't think it will be. 1 and 4 and 2 and 2. And we're good to go. So now we do a little bit of the trial and error part of the tricky trinomials. And again, you can get pretty good at this in your head, okay, from the tricky trinomials video. All right, so you try the numbers. Now typically, the little cheat is that 2 and 2, right, the numbers that are closest together are the numbers that you go with. For some reason, that's just what the Regents does. They rarely ever use 1 and 4, which is probably what they use in this problem. But anyway, so we try the 2 and the 2. So I'm going to do, oh, forgot my x. So 3x and x. So we have our outside and our inside that we have to try. Okay, so we get 2x here. We get 6x here. And 6x and 2x, just not going to make the 11x. So that doesn't work. Okay, so we can cross that one out and try again. Since it has to be 3x and 2x, okay, 3x and 1x, I apologize, 3x and x, we don't change that. 2 and 2 switched isn't going to work, and this is where you start to think ahead. How do I get 3x and x with a 1 and a 4 to get somewhere near 11? Well, I know that 3 times 4 is 12. That's my outside portion. So I'm thinking, you know what, that gets me pretty close to 11. So then if I put the 1 and the 4 there, or 1 and the x there, I apologize, it's going to give us 1x. Can 12 and 12x and 1x make the 11x that we need? And the answer is yes, if we have the signs correct. So I'm going to need to have a positive 12, I'm going to need to have a negative 1, and now that I've got them, life is good. That makes our positive 11x. So to get to having a positive 12, I had to multiply 3 by a positive 4. That means the 4 must be positive. To get to have, though, a negative 1, I had to multiply x by a negative number. So that means this must be a negative 1 because I can't change the x. So I have a negative 1 here. The last thing you need to check is to make sure that the negative 1 multiplied by the 4 does in fact equal this negative 4. And it does, so we're good. So hopefully you've remembered, all right, in doing all that, that your 3x minus 1 and your x plus 4 technically should have been set equal to 0. And it needs to be solved. This is a system. So we're going to solve. This is the part I was talking about before when I said you really want to make sure you set them equal to 0, because if you don't, you're just going to add 1 over in your head and say, oh, yep, x equals 1 and x equals negative 4. Now over here, getting x equals negative 4 isn't going to be a problem. That's right, switching the sign is okay, but over here, switching the sign and saying x equals 1 is wrong, very wrong, and not helpful to getting full credit. So you have to add 1 and then divide by 3. It's actually 1/3 when you solve that. So again, we have to add 1 over, divide by this 3, and we get x equals 1/3. And again, half my students, it seems, look at this problem and go, hey, look at that. That was a lot of work. I'm done. And unfortunately, you're not. You have now solved for the x's. You need to solve for the y's. So we're going to plug back in. And again, please don't choose crazy. The first equation is just nasty. I don't want to plug 1/3 in there. I don't want to be squaring that, multiplying it by 21. That is not fun. Okay? And I'm a math teacher. That's not fun. So y equals 10x minus 1. Come on, scroll up. Is the equation that we're going to use, and we're going to plug them both in. So 10x minus 1, y equals 10x minus 1. I'm going to plug in my 1/3. So I get 10/3 minus 1. And this is where your calculator becomes really nice. And not that you can't do this in your head, but you can completely type this in. So you could have typed it in at this line, 10 times 1/3 in parentheses minus 1. It's going to spit the answer out of 7/3, which is really nice. Now, for those of you who are pretty good at math, it should not be hard for you to look at 1 and say, hey, that's really just 3 over 3. So 10 minus 3 is 7, and then the 3's in the bottom stay the same. That shouldn't have been rocket science. All right, moving on to the next problem. Next part of it, I should say. So 10 times the negative 4 we plug in. Okay, plug in the other x value, minus 1. So 10 times negative 4 is negative 40, minus 1 is negative 41. And now we have our y values. And again, if you stop here at least you'll get 3 points. Right? Stopping way back up here gets you 2, stopping right here gets you 3, and writing them as ordered pairs, well, that gets you full credit, which is what I'm really hoping you get. So we have 1/3 with the y value of 7/3. When I look over here, the x value of -4 when it was plugged in gave us a y value of 41. So -4 and -41. Now, a nice way to double check this would be to take the two original equations that you have, the y equals 10x minus 1, and the other y equals equation, and this thing isn't going to let me scroll up, so that must have been the 3x squared plus 21x minus 5. Type in both the original equations, when they're in their y equals form, that is, and find the point of intersection. You can double check it. Alright, that's it.